Haynes Sleep Manual. All we need to know in one concise manual. The role of chemicals. Histamine. Histamine is a neurotransmitter. It's present in large quantities during wakefulness, decreasing during REM sleep, which is why histamine-blocking chemicals called antihistamines cause drowsiness. Histamine then increases during non-REM sleep. Melatonin production and circadian rhythms. Serotonin is used throughout the day. It produces melatonin in the dark, which is called the sleep hormone. This production is inhibited by light. Melatonin is thought to be linked to circadian rhythms. For this reason, jet-lagged travelers who have difficulty with sleep may take medication to adjust their sleep cycles to match daylight and darkness in their new locations. Towards the end of the night, the body starts to secrete cortisol in proportion to the stresses of the day in what's known as the cortisol awakening response. Circadian rhythms and desynchronization. Circadian rhythms is the mental, physical, and behavioral changes that follow roughly the 24-hour cycle, sometimes called the biological clock. When there's more light, a part of the brain called the SCN tells our body to produce more melatonin, which causes drowsiness. Overnight, melatonin remains high and drops at daybreak, remaining low throughout the day. Other neurotransmitters, namely noradrenaline and acetylcholine, increase in the body throughout the day, keeping us more alert. It's these chemicals that make it difficult for night shift workers to sleep throughout the day. For more on these neurotransmitters, type in "What is the role of noradrenaline?" into Google in AI mode. The SCN is also influenced by other factors, such as our place in the circadian cycle. The above explains why jet lag occurs. To find out more about the SCN, type "What is the SCN in the brain?" into Google in AI mode. The problem with the night shift. Nighttime workers are expected to be alert when the brain is secreting melatonin, a sleep hormone, then sleep in the day when it's not secreting a sleep hormone, but is in fact secreting wake-up and alertness hormones called noradrenaline and acetylcholine. This means they on average 1 to 1.5 hours less, and REM is the casualty in this. REM sleep. I got the following information by typing into Google in AI mode, "What body functions does REM sleep perform?" Sources of these docs include Harvard Health, National Institute of Neurological Science, etc. Beginning of the AI search for "What body functions does REM sleep perform?" REM sleep performs vital functions like memory consolidation, emotional processing, learning, brain development, and physical recovery by boosting brain activity similar to wakefulness, while temporarily paralyzing most muscles to prevent acting out dreams, helping manage stress, strengthen neural connections, and support overall mental and physical recovery. Cognitive functions. Memory and learning, strengthens neural connections, helps consolidate new information and skills, especially procedural memory, and prunes synapses to improve problem solving. Emotional regulation processes emotional memories like fear, helping to manage stress, anxiety, and maintain emotional balance. Brain development, crucial for the development of the central nervous system, particularly in infants, who spend much more time in REM sleep. Physical functions, muscle paralysis, atonia, muscles become limp except for breathing and eyes to prevent acting out dreams, a key characteristic of REM sleep. Cellular repair, contributes to overall physical recovery and immune function, helping the body fight infections. Brain maintenance reorganizes and catalogs memories, acting like a librarian for the day. End of the results of the AI search for "What body functions does REM sleep perform?" It takes 10 days for the body to adjust to circadian nighttime work. Long shift patterns with 4 to 6 weeks of days or nights would be best. 4 to 7 night shifts in a row is thought to be the worst possible, resulting in a permanently desynchronized person who doesn't fully adjust to day or night. People who suffer from chronic sleep difficulties can, in effect, suffer from the same sort of desynchronization, especially if they sleep in parts of the day to catch up.